Okay, we're gonna look at restricting the domain, and then we would do that to have the inverse be a function. So we're gonna use example 2 and work our way through that. Given the function f of x equals x squared minus 2, sketch the function and determine whether its inverse is a function. So we're gonna sketch the function right here. So this is a parabola shifted down 2. So I'm gonna go down 2 for the vertex, over 1, up 1, over 2, up 4. Got lots of room on this graph, so I'm gonna draw it a little bit bigger. Over 3, so 3 squared, I'd go up 9 from that vertex. So we have a nice full graph right here. So we're gonna connect these points. We're gonna have our U shape, and we're gonna label this graph f of x. Then it says, determine whether its inverse is a function. So rather than drawing the inverse and doing a vertical line test, we can do a horizontal line test. So if we do a horizontal line test, it would cross the graph twice. Therefore, the inverse is not a function. So let's have a look then and write that down. Inverse is not a function, and we'll just put in brackets, because it fails horizontal line test. Now you don't have to say why if the question doesn't specifically ask why, but we want to write that down in our notes so we understand why. Okay, then let's look at B. Sketch the inverse of the f of x on the same coordinate axes. So for B, we're going to list these points. So f of x, we've got the point -3 and 7, -2, 2, -1, -1. Then we've got our vertex here of 0, -2. Then we've got 1, -1. We have 2, 2. And we have 3 and 7. So for our inverse, we're going to just switch x and y. So we're going to rewrite all these. And we're just going to reverse the order of these. I can tell that that's going to be an invariant point since I didn't switch -1 and -1. 2, 2 will be another invariant point. And now we're going to sketch this. I'm going to use a different color of pen just so that stands out. So we're going to plot 7 and -3, 2 and -2, -1 and -1, -2 and 0. That's actually my new vertex. -1, 1. 2, 2 is another invariant point. 7 and 3. And you'll notice once you've done this, this is a reflection over the y equals x axis. And what's happened is that you have now a sideways parabola. We'll call this the inverse. The inverse is not a function, so we can't use function notation, which we're going to talk about more in the next video when we look at C. I also want to talk a little bit about a shortcut method with this now that we've seen the results. If you have an inverse of a parabola, if it opens up, it's going to turn into a parabola, the inverse, that's going to open to the right. So often what I do is I just then use the vertex and know that if it's 0, 2, I switch that, I'm going to plot -2, 0, and then I know if it opens to the right, I just plot that shape. In fact, we're so used to graphing parabolas, I tend to turn my paper sideways, and once I have that vertex, I still go over 1, up 1, over 2, up 4, over 3, up 9, because you can certainly turn your paper sideways to graph that and use that counting like you're used to with parabolas. So watch the next video for example 2C.